Hi again. Welcome to the second video on log laws. Here we are going to discuss 6 examples of the use of the laws to simplify expressions and solve equations. So in summary, log a to the base a, which is any number to its own base, is equal to 1, always. Log of 1 to any base is equal to 0. If we have a product, log xy, then that's equal to the sum of the logs, log x plus log y. And that's what you say to yourself, the log of a product is equal to the sum of the individual logs. If we have a division, x over y, then the log of that quotient is equal to the difference of the individual logs. If we have an index in there, so it's log x to the n, then we just bring the index down, so it's n log x. So we're going to use that log law for creating an index from a coefficient and vice versa. And then the last log law was our change of base relationship, where log x to the base y was equal to log x to another base over log y to another base. So we could use that very easily. Now some quick examples. Log of x to the base 5 times log 5 cubed to the base x, we have to prove to be equal to 3. Now the left-hand side, our first step is to get rid of that index. So log of x to the base 5 times 3 log 5 to the base x. Now we're going to change our base. So log of x to some base over log of 5 to the same base times 3. And then log 5 over log x to the same basis as we started with. Equals, now the log x's cancel out, the log 5's cancel out, so we're left with 3, which is equal to the right-hand side. Next, we have to simplify log 54 to the base 4 minus 2 log 3 to the base 4. The 2's in the road, so we're going to get rid of that. So log 54 to the base 4 remains untouched, and we take the 2 up to the top, so minus log 3 squared to the base 4. And now we've got the difference between two logarithms, so we can now write log of 54 over 9 to the base 4, and that simplifies, of course, to log 6 to the base 4. Third example, we're given that log b to the base a is 2.75 and log c to the base a is equal to 0.25. Now we know nothing about a, b and c, that doesn't matter. So the first question is, evaluate log of b over c to the base a. Well, as soon as we have a fraction, we know we can subtract those logs. So the fraction thing is log b to the base a minus log c to the base a. Now we've got our numbers for that, so it's 2.75 minus 0.25, which is 2.50. For the second part, we're going to have log b c all squared. So, of course, with an index, we're going to bring it down the front, so it's going to be 2 log bc to the base a, but bc are multiplied together, so we turn that into the sum of our logs, and so it's 2 outside of log b to the base a plus log c to the base a. We've got those numbers, put them in, 2 times that is equal to 6. Fourth example, we have to solve the following equation. Log of 7x minus 12 is equal to 2 log x. The 2's in the road, so we're going to take it up to the index, so it's log 7x minus 12 equals log x squared. So here we have the log of a number equals the log of another number. So the logs are the same, so the numbers have to be the same. So we can write 7x minus 12 equals x squared. Tidying that up, we get the quadratic, x squared minus 7x plus 12. Factorise it, solve it, and then check with the original equation to make sure your two values work. Because remember, we can't take the log of a negative number. So we have 7 times 4 minus 12, which is 16, positive, greater than 0, it's okay. Put in the 3, same thing, 9, greater than 0, okay, so both those values are fine, so x equals 3 or x equals 4. Now an equation a little bit more complex. We have log of x minus 1 to the base 2 is equal to 5 minus log of x plus 3 to the base 2. So we're going to get the right-hand log across to the left, so we can write log of x minus 1 plus log of x plus 3. So now we've got two logs added together, so we can multiply them together. Log of x minus 1 times x plus 3 to the base 2 is equal to 5. get rid of the base by bringing it across to the right hand side, and then we can get rid of our logs. So it's x minus 1 times x plus 3 equals 2 to the 5th. Quadratic, solve it, and we find that x equals minus 7 or x equals 5. Now checking to make sure the values are okay. If x is equal to minus 7, then the first term, log of x minus 1 to the base 2, gives us minus 8. So that's no good. Can't take the log of a negative number, so it's not possible. We did the same with the 5, we'd be okay. So we'd have 5 minus 1, which is 4, 5 plus 3, which is 8, so no problem. So the only solution we've got is x equals 5. Must always check to make sure that those values that you've calculated in a quadratic are possible. So last example. We're given y is equal to x e to the kt, and we have to find the value of k given these values. So we write down the equation, we substitute into it, and then we divide both sides by 10. So we're left with 0.8 is equal to e to the 20k. Now we can take the logarithm, so it's going to be log of 0.8, and the e swings down to be the base of the left hand side, is equal to 20k, divide k is equal to log 0.8 to the base e over 20, put that into your calculator and you get minus 0.0112. Going to be doing that one a fair bit, make sure that's really clear. You now have both a summary of the basic log laws and examples of their applications. Please develop your expertise to a higher level. It's actually quite satisfying doing these problems because there are really no nasties. Try the test yourself one questions on my website at drjsmaths.com and look back at the first video for consolidation if necessary. Hit the like button, subscribe if you haven't already. Good luck. See you later.